Okay, good evening, everybody. We're going to start talking about Chapter 8, which is exponential properties. We already did this early in the year, so hopefully it'll be a bit of a review for us, and we'll do be a little bit easier for us since we've already seen it once. So I'm going to go kind of quickly through these today, and I have a couple of pretty decent-looking examples towards the end that we'll do together, and you can see how it's applied. All right, so here we have exponential properties, and so we have we're multiplying x times x. So our file type for this one, if you recall back, the file type would be multiplying the same base. And the technique then would be add exponents. Okay? So here, my base is x, so I'm multiplying the same base. I have an exponent of 1 and an exponent of 1, so x times x equals x squared. Now, where we are forgetting this most often is when we're given a problem that looks like this. X plus 2 times x plus 3. And we do a generic rectangle. And we have x and x there. Many of us are still forgetting that this box right here needs to be x squared. So it does need to be x squared. So that would be x squared in that box. So that's kind of where I'm seeing that error so far this year. Is when you are doing a multiplying binomials using a generic rectangle. Okay, so that's that one. Pretty simple. Same file type and technique for this one, so that doesn't change. In this case, my base is 3y, 3y, and 3y. Or you could look at it as a base of 3 and a base of y. And you'll see we get the same answer. So I'm going to do it that way first. So the base of 3 would be 3 times 3 times 3, which is 3 to the first times 3 to the first times 3 to the first, which is equal to 3 to the third. And then you also have y times y times y, which is y to the first, first, and first, which is y cubed. So then 3 cubed times y cubed would give me 3 cubed y cubed, like that, for my final answer. And the other way you can look at it is this is one base, so this is like this to the first power, and that's like that to the first power, and that's like that to the first power. So then you would have 3y to the third. And these two are equivalent, all right? They're the same. I guess I should go ahead and mention the other way you could write it would be multiplying the 3y out. That would be 27y cubed, which would be the same. We're going to see a little bit later, remind ourselves how this is the same thing as this. This is a different file type here. But if you're looking at this as a base and a base and a base, then you would have 3 3y's, so that'd be 3y to the third power. Okay, now we look at the next one down here, and these aren't the same bases because I have a 6 here and a 2 here. So those are just coefficients, where here I had 3's. But even still, when I had 3 times 3 times 3 on top, I could multiply that to 27. So 6 times 2 multiplies to 12, just like that. And then this is a different base, and that's a different base. So I'm going to write them in there. I can't add exponents because I don't have the same bases. So it's going to be x and then y, and that's my final answer there. And the last one down here, I go ahead and see that I have coefficient here, coefficient there, so I can multiply my coefficients, and I get 8. And then I have same base here, same base here. That's an exponent of 1, that's an exponent of 1. So that'd be x to the second. I add my exponents, and base are the same. So that's y to the 1 plus 5, which is 6th. Okay, so that's the basic review there. The next ones we'll take a look at. Alright, so similar setup. I wrote it like this because a lot of times we think that if we have parentheses, then it must be raising a power to a power. That's not the case. The file type here is multiplying same base. Okay, it's the same as before. The technique, add exponents. Okay, So for this first one here, my first thing I'm going to do is I'm going to multiply my coefficients. 2 times 3, which is 6. And then my base is x, and my base is x. So that gives me x to the 2 plus 5, which is not 5. It is 7. So 6 times x to the 7th. Okay, same file type and technique for this one. And so I have a base here and a base here. Since those bases are the same, it's okay for me to write 5 to the 2nd because I have an exponent of 1 and an exponent of 1. And then I'm going to do these alphabetical. So I see that my next one I have is y and y. So that is going to be y to the 2 plus 4, which is 6. And then my last one is z and z. And that's z to the 1st, and so z to the 4th. It's a very good idea to put in these right here, the ones, to remind yourself that you need to add your exponents. Okay, now, the next one down here is different. This is a different file type. The reason it's different is because I have an exponent outside of my parentheses. I have exponents here and here as well, but it's an exponent of 1, so that doesn't change anything. When I have an exponent other than 1, that changes my file type. And so this file type we decided was raise a power to a power. Okay, so raise a power to a power. And when we raise a power to a power, the technique that goes along with that is to multiply exponents. So when we multiply same bases, we add exponents. When we raise a power to a power, we multiply exponents. Now here's where it's super important to do this thing right here. If you don't see a 1, if you don't see an exponent on any of these, some of these numbers, it is to your advantage to go in there and put a 1 in there, just like that. Now I see an exponent that I'm multiplying. The biggest mistake is students say that the answer is 4x to the 12th. They remember to multiply 3 times 4. They don't remember to multiply 4 times 1. So the answer should be 4 to the 4th, x to the 12th. And that's my answer there. Alright, take a look at the next slide. Okay, these will go a little bit quicker because it's just practice. So this is file type power to a power. And technique, multiply exponents. I know that handwriting's not very neat, but you should be listening as well as writing it down. So a good first technique is to go ahead and put in a 1 there, like that. So now when I raise a power to a power, I get 4 to the 3rd, x to the 6th. So I multiply my exponents. Now these next ones are a little bit different. The key thing you want to look at here is, what is this square affecting? And the square is affecting parentheses only. So that means this doesn't change. That is not being affected by that 2 there. So I'm going to go ahead and put in my exponent like I like to do. So then, since this negative 3 is not being squared, it's just going to stay negative 3. And then I raise a power to a power. X to the 1st times 2 gives me x to the 2nd. So, that's my answer, negative 3x squared. Now, because where this parenthesis is, it is affecting the 3 this time. So they're both inside the parentheses with a square on the outside. Therefore, that means that both of these need to be getting a 1. And I'm now raising a power to a power. So I have negative 3 times. Now, you're going, why did he suddenly start using parentheses? I use parentheses because I'm going to emphasize something right here. This is negative 3 squared, which means I can write that as negative 3 times negative 3. So negative 3 times negative 3 gives me a positive 9. So this is a positive number, because negative 3 squared gives me positive 9. So my final answer here would be 9 positive x squared. Okay, so that's why I did those parentheses in there, just for emphasis on this particular problem. All right, so this next one, I don't see any parentheses, which means that this cannot be affecting the 3 because there's no parentheses. The only way this affects the 3 is if it's inside parentheses like the one above it. So since it's not, the answer to this one is negative 3x squared. There's nothing else you can do. That is my answer. And finally, the last one here, I do have parentheses, but I don't have an exponent outside. So that means my exponent is 1. So if I have an exponent of 1 out here, I'm going to go ahead and write that in. And now if it's raising a power to a power, okay, well that's a 1 right there. So 1 times 1 is 1, so that gives me negative 3 and x squared. So you'll see that it didn't change anything from the original. All right, so what I want you to notice here is in these 4 problems, 3 of them are identical. This one and this one. So these 3 give me the exact same answers, even though they start completely different looking. The only one that was different is this one, and so the main thing you want to write down in your notes in your 5th color is why is this one different? How come this gets a totally different answer than any of these 3? All right, and the last section, just going to do a couple more complicated problems with you guys, and I'll do them relatively quickly. And whoops, let me make that a little bit smaller. It's supposed to be an exponent. 2 to the 4th cubed times negative 1.5 p to the 7th. Okay, so I'm going to go ahead and do this one. So this is a raise a power to a power to start with. So this is a power to power. And so I need to come in here and put in my my exponent there. Now this negative is outside, therefore it's not being affected by that exponent. So that means I'm just going to leave it out there. So I have negative, and then 2 cubed p to the 12th. And then this is being multiplied by negative 1.5 p to the 7th. So then I see I have a coefficient here, which I'm going to go ahead and simplify out that coefficient. So 2 to the 3rd gives me 8. So this is really negative 8 p to the 12th, negative 1.5 p to the 7th. If you're not sure why that's negative, make sure you ask me in reflection tonight so that you get that clear. So now I have negative 8 times negative 1.5, so that gives me, what does that give me? That gives me 12, and it's positive because the negative times the negative is positive. And here I have same base here, so now at this point it's multiplying same base. Okay, so I multiply same base, I add my exponents. So I get p to the 19th. Okay, so you notice that we started off at power to a power, and then we went to multiplying same bases. Okay, so we're going to do the last problem here. And so we have 1/2 y to the 5th cubed times 2y squared to the 4th. Once again, I see that I have exponents on the outside, so I need to go in and put in exponents on the inside. So this right here gives me the fraction right here, raised to the 3rd power, is equal to this. 1/2 times 1/2 times 1/2, because 1/2 is being cubed 3 times. So that means it's 1 over 2 to the 3rd, or you could say 1 to the 3rd over 2 to the 3rd, which is equal to 1/8. Okay, so the fraction part right here, raised to the 3rd power, is equal to 1/8. Now I'm going to do my variable. So that is y to the 15th, and that's that first one. Now I'm going to do the same thing on the second one over here. So the second one, I have this. That gives me 2 to the 4th. Actually, I'm going to go ahead and multiply that out. So 2 to the 4th gives me 16, and then y to the 8th. My last thing I can do is multiply my coefficients and multiply my same bases. So 1/8 times 16 is equal to 2, and y to the 15th plus times y to the 18th is equal to 23. So my final answer is 2y to the 23rd. Okay, that's the notes for tonight, and I'll see you guys tomorrow.